The most important property in machine design is the mechanical property. In this section, we discuss about the overview of mechanical properties. Mechanical properties are main properties that defines the behavior of materials against external forces. You should first understand the four main mechanical properties: rigidity, strength, hardness, and ductility. Rigidity, also called stiffness, is the resistance to deformation. Strength is the ability of a material to withstand force and destruction. Hardness is the resistance to force applied locally on material surface. Ductility is the resistance to destruction caused by sudden force. Another important mechanical property is fatigue strength. Fatigue strength indicates the resistance to fracture due to fatigue. In my experience, most of the troubles encountered in my machine design work were caused by failures caused by fatigue. The machine designs that I was engaged was the design for model changes of products that already have released. So, the main mechanical properties, stiffness, strength, hardness, and ductility, were well considered in the first product development phase. In a machine design, one may design mechanical parts referring those of similar parts or products. Under such condition, troubles are possibly caused by fatigue, which is more difficult to predictable than the other main mechanical properties. These mechanical properties also have the aspect of properties that are defined to be applicable for practical works of machine design. Unlike physical and chemical properties, they are strongly interrelated, and some people may be confused, wondering why these properties should dare to be defined. Here, it is important to understand mechanical properties with their definition as well as their purposes for practical use. First, you may understand the mechanical behavior with respect to the image of a metal spring. A material exposed to external force leaves the elastic region and goes through plastic deformation to break. In the elastic range, when you pull the spring, it gradually stretches and returns to its initial position after releasing the spring. As you increase the force to pull the spring, after exceeding certain amount of force, the spring does not return to the initial position. This means that the material has entered the plastic range. This is called permanent strain. If you still continue to pull on it, the spring eventually breaks up, which is called fracturing. This behavior is true not only for springs, but for materials in general. Once you get the general image of how materials behave, you should first intuitively understand the relationship among machining and elasticity, plasticity, and fracturing. The mechanical products that are the outcomes of machine design include structural components. Elasticity, plasticity, and fracturing are important for ensuring the function of structural components. If a part enters the plastic range while the machine is operating, the shape of the part changes, resulting in the failure of machine function. Failure of machine parts may cause serious accidents. So, we can only guarantee the function of the material within the elastic field. In elastic field, a material can return to the original shape by releasing the force. In addition, the conditions of use should be considered to ensure that fatigue failure does not occur. We can think of plastic processing as an application of the plastic field, and machining as the application of fracturing. Let's consider practical examples of how these properties are applied. An example of application of elasticity would be a clip. Clips are widened out a little. Clips are widened out a little and hold paper between them. This takes advantage of the material's elasticity, its tendency to return to its original shape. Press forming makes use of the plasticity. In a press forming, a thin metal plate is sandwiched between dies to create an uneven surface. Machining tools are making use of fracturing for material processing.